Hello, and welcome back to the Ninox Learning Channel by Nioxus Corporation. My name is Andy. I'm a Ninox programmer and trainer at Nioxus. And in this class, we're going to explore something a little bit different in the Ninox system. In all of the other classes, we've talked about how to get Ninox to do the things we need and want it to do. In this class, we're going to talk about how to get Ninox to do the things we need and want it to do faster. Today we're going to talk about performance and speed optimization. Little tricks, little tips, things that you can do very easily. They don't require much code. These are little things that you can do that are going to significantly improve the performance and increase the speed with which your Ninox system operates and performs. I'm going to show you 3 things, all easy to do, and all of them will have a dramatic and very positive impact on how your database performs. Let's go ahead and get started. The first thing I want to show you is probably the easiest tip we can offer that gives the greatest bang for the buck. It takes maybe 5 seconds to make this change, but the impact on performance is profound. It's huge. Let me give you an example. We're here in our cash flow projection template. You can download this from our member website. And in this template, we set up all of the cash receipts and all of the cash disbursements that we receive and distribute throughout the year. And then we go ahead and we calculate what our cash balance is going to be in our checking and savings accounts on any specific day of the year, given our projected cash flow. To get this system to work properly, the first thing we have to do is set up the receipts and the disbursements. So we're going to go into the receipt header, and I am going to create a receipt, say from work. And it is going to start on the 15th of the first month of the year, January, and every 15th day of every month for 12 months, we're going to receive payroll. We're going to receive $1,500 in payroll on the 15th of each month. When I click this button, what we're going to do is execute a very simple for loop that is going to repeat, in this case, 12 times to create my 12 monthly payroll receipt records. And let's go ahead and do that. I click the button, and as you can see, the system is now creating each record for the first, second, third, fourth, all the way through the 12th month of the year. What you also can see is it's taking 1 to 2 seconds per record. And there we go. 12 records created in about 25 or 30 seconds. Now we also get paid on the 30th of the month. We get paid on the 15th and 30th of the month. Let's set up this second receipt. Again, we're going to be paid from work starting on the 30th day of the month. And there'll be 12 receipts. And again, we receive $1,500 per paycheck. This time, however, I'm going to go into administrative mode and make a very simple change. I'm going to type 4 words. Do as server, and then one more word, end. That's it. 4 words, about 5 seconds of programming, and now let's see what happens. We'll save our changes, we'll exit administrative mode, and again we're going to create the same 12 records. Less than 2 seconds, all 12 records have been created. A moment ago, this exact same block of code took almost half a minute to create these dozen records. With those 4 lines of text, 4 words, do as server and end at the bottom, we have increased the performance of our system. We have improved the speed of creating those dozen records almost 1,000-fold, almost 10 times the improvement in timing, from 30 seconds down to about 1.5 or 2 seconds. It's important to understand that when you are running Ninox in the cloud, and this little trick only works for cloud systems. This does not work for the locally installed or downloaded app. But if you are running Ninox in the cloud, your database is stored in the cloud. All of the content in your database is similarly stored in the cloud. But by default, any code that you write is going to be executed locally on your local computer, whether it's a laptop, a desktop, a phone, or a tablet. Code is executed locally. So now, when the code is executed, the quality of your internet connection, the speed of throughput through that internet connection is going to have a dramatic impact, not to mention the functional processing capability of the device that you're using. All of these things can serve to slow down the processing. But with these 4 words, do as server as the first line of code and end as the last line of code, we are instructing Ninox to do everything inside those 2 lines of code on the server where your database and content are stored. How much RAM you have, how fast your hard drive is, the quality and speed of your internet connection is now significantly less important with regards to how fast this code can be run, because all of the code is going to be run on the server, which is almost certainly more powerful than your local device, your smartphone, tablet, desktop, or laptop. And by not having to move the code and move the results back and forth through your internet connection, we cut out a lot of the things that drag down the performance. So the first thing I want you to remember is when creating certain blocks of code, or for that matter, you could do it with all blocks of code, but some blocks respond to this better than others. Enclose the code in a do as server loop. The first line of code, do as server. The last line of code is the end of the loop. Now, I said that certain blocks of code respond better than others. There are 2 functions in Ninox that tend to be slower in execution, irrespective of what kind of computer you have, irrespective of your database. In general, the create function and the select function will slow things down more than any other function. And here we see on line 10, we are, in fact, creating not 1 record, but 12 records in this case. Without the do as server, it took 20 or 30 seconds to create 12 records. With the do as server, it took less than 2 seconds, and that was just 12 records. Imagine if you had to create 100 or 1,000 records. If we extrapolate the speed and performance improvement generated by simply doing the work as a server-side program as opposed to a client-side, doing it on the server versus running the code on our local machine, if we take the improvement that this can create in performance and calculate the impact over thousands of records that have to be created, all of a sudden, functions that used to take minutes, in some cases 10 or 20 minutes, will now take 3 to 5 seconds. So remember, when creating records, when running a loop that is duplicating or creating content, run it server side. Do as server. That's our first tip. Now the second tip and the second function that tends to slow things down is the select function. The select function and the speed with which it is executed is directly related to how big the file is. How many records are there in the table that we are interrogating? Let's imagine we have a table of 120,000 invoices. We process invoices 12 months out of the year, and our customers are spread across 3 countries: Mexico, the United States, and Canada. Let us further imagine that we process about the same number of transactions every month. If we have 120,000 invoices in 1 year, we're going to have about 10,000 invoices per month for the 12 months of the year. And let us further assume an unequal distribution. Maybe 30% of our work is done in Mexico, 30% is done in Canada, and the rest of it is done in the United States. But imagine this massive table with hundreds of thousands of records representing many years and many months and many countries with whom we've done business. What we're now talking about is the sequence of the selection. And what I mean by that is this. A compound selection statement is one where there's more than one criteria or more than one filter included in the statement. In this example, we want to select all records from the customer invoice table according to 2 filters, by country and by month. Let's look at these metrics to better understand how the sequence can have such a dramatic impact on the performance of our system. We conduct approximately 120,000 sales transactions per year, and they're pretty evenly distributed across the 12 months of the year. So roughly 10,000 invoice records are created each month. We sell to customers in 3 countries: Mexico, the US, and Canada, with about 20% each of our sales going to Mexico and Canada, and about 60% to customers here in the United States. We operate 12 months out of the year, and we have 5 years of data in our system. 5 years of data with approximately 120,000 records being created every year means we have an invoice table with approximately 600,000 records. 600,000 customer invoices have been created over a 5-year period. What we want to do is select out of those 600,000 invoices by country, by month of sale. Let's look at how the sequencing can have such a dramatic impact on the speed and the performance of this simple select statement. First, we're going to select all invoice records where the country code is M and the month is 1. Now, Ninox will execute these queries as one query, but they will filter the query sequentially. First, out of the 600,000 records in the table, the system will filter out all but about 120,000. Remember, in Mexico, we do about 20%. 20% of the 60,000 records means about 120,000 will result from this first filter, where country equals M. Out of this 120,000 records, that's over a 5-year period. We know that the records are evenly distributed by month. So 120,000 records divided by the 5 years, which is 60 months, is about 2,000 Mexican sale invoices per month. There are 5 Januaries over a period of 5 years. So we end up with 2,000 times 5, 10,000 records out of the original 600,000 were sales made to customers in Mexico in the months of January. Let's look at the exact same query with the sequence reversed. We're going to again select invoice records, but first we're going to select by month. Now, out of these 600,000 records, we know that they're pretty evenly distributed by month, which means about 1/12 of this 600,000 is sold in January, and there are 5 Januaries, which means we are selling approximately 50,000 transactions in January. 1/12 of the original 600,000. Now, out of these 50,000, approximately 20% are being sold to customers in Mexico. 20% of 50,000, again, as we would expect, we come up with the same answer. 10,000 records for invoices for sales made to customers in Mexico in the month of January. But let's look at how we got here. To find these 10,000 records, according to this sequence, country, then month, we had to find 10,000 records amongst 120,000 records. In the second example, when we simply reversed the sequence, we still had to find 10,000 records, but we only had to look at 50,000 records to find them. Now, if you're looking for 10,000 things, and you can look for those 10,000 things in a pile that has 120,000 things in it, or another pile that has 50,000 things in it, what takes longer to search? A stack of papers with 120,000 papers, or a stack of papers with only 50,000 papers? And of course the answer is you can search through 50,000 items much faster than you can search through 120,000 items. As a result of just changing the sequence, instead of country, then month, we will select by month, then country. We'll still end up with the exact same answer, but to get to that answer, we cut more than 50% of the processing time out when we conducted the second query. Because the second query was executed on a much smaller array of records, the second query executed more than twice as fast. The answer was the same. The query was the same. All we did was change the order of the filters. So the second thing I want you to understand is when you are working with compound queries, like a create, you're executing a statement that takes a little longer than most. So the order in which you execute the multiple queries, the compound queries, is going to have a dramatic impact on how long it takes to get from all of the records in the table down to just those records you were looking for. As you build your queries, think about the result of each filter in the compound query and put the filters that will reduce the total array of possible records to the smallest array possible first. When country was first, we reduced the 600,000 down to 120. When the month filter was first, we reduced the 600,000 down to 50,000, less than half when it was in the other order. This query, how many of these records out of 50,000 were for sales to Mexican customers, is going to execute more than twice the speed, at more than twice the speed of this query here. And to truly supercharge this, put the statement inside of a do-as server. So it ultimately would look like this. and I'll get rid of the bullet points. And we would have a statement that says do as server, and then we would have this statement, and then we would have the end. So this statement here is going to give us the fastest possible path from the 600,000 records that we started with to the 10,000 that we wanted to end up with. We utilized our do as server loop to make sure that we executed server-side processing as opposed to client-side processing. And we optimized the sequence of the two filters to ensure that we had the smallest possible group when we executed the second filter. Because we can find something amongst a small group of things much faster than we can find something amongst a large group of things. And also, when it comes to moving things or manipulating these arrays in and out of our random access memory, our RAM, big things move slower than small things. It takes a lot less time to move 50,000 records in and out of memory than it does to move 120,000 records in and out of memory. So if you're dealing with big databases and you're performing selections on those big databases, and those are compound selections, pay particular attention to the sequencing of your selection and perform the selection inside of a do as server loop. Now let's return to Ninox and take a look at the third trick or tip that I'd like to provide you today that is going to speed things up a great deal when you are interrogating or querying or selecting records in your database. Let's look at the third thing that we can do to significantly improve the performance and enhance the speed and throughput of our Ninox system. And again, we're going to talk about the select statement. The select statement produces an array. And there's a number of videos on the Ninox Learning Channel by Nioxus where you can understand and learn how we work with arrays and how we work with select statements. And I encourage you to look at those videos when we're done here today. But the result of a selection is a sub-selection of records. And we call that sub-selection an array. Now imagine that we have a dashboard. And this dashboard is going to interrogate our disbursement transactions and our receipt transactions. So I'm going to create the dashboard table. And we would have, in this example, let's say we set up the 12 formulas to do the monthly interrogation of the receipt transactions. Go ahead and move that up so we have it in order. I'm not going to create all 12, but you get the idea. Each of these formula is going to be pretty much the same. Select, receipt, transactions, where month, in this case, equals 1. Now, we're going to execute this select query 12 times to query the receipts and 12 more times to query the disbursements. And as I've already mentioned to you, a select statement tends to be a little slower than the other statements, many of the other statements in the Ninox language. So we're going to have a statement that we already know can slow things down, and we're going to execute it 24 times. But it's the same statement every time. We're simply selecting receipt transactions and then filtering out the month. We're building the array over and over and over again, simply to select out the first, second, third, all the way through the 12th month. What you can do in a situation like this is create a master array formula. Let's call this the invoice selection. And the invoice selection is going to be select all of the receipt transactions. Now we have a selection in this formula. What we then can do in each of the subsequent formulas is interrogate that selection. Instead of reselecting 600,000 invoices to find January, then selecting the same 600,000 to find February and March and April, we select the 600,000 once. And we put that selection as an array into this table, into this formula called invoice selection. Then we simply query the formula. We select all of the records in the invoice selection array where month is 1 or 2 or 3 or 4, all the way through month 12, which would be December. If we have to select and then query 24 times, there's no reason that we have to select the array 24 times. Select the array once and then query that array as many times as you want. We know the select statement can be a little slow when you're selecting in big databases. Embed this selection, which is going to return 600,000 records, inside of a do-as server, so you have server-side processing, which is very fast, instead of client-side processing, which can be significantly slower. And then reuse that selection, reuse that array over and over and over and over again to get the different results for January and February and March, all the way through July and through to September and December for your transaction receipts, your transaction disbursements. By doing it this way, you're still getting the answers you wanted. What are our total sales per month over the 5 years that we've been in business? But you're going to get the answer much faster because you executed this massive query one time and you executed it server-side. You did it as a server-based block of code. So let's quickly review what we've learned today. Anytime we have large, complex blocks of code, maybe hundreds of lines of code, or when we have a block of code that has a select statement that has to go into a big table and create a subset or an array of records, especially if it's going to be based on compound or multiple filters. Or we have to repeat a select statement over and over and over again, or we are creating records not by typing in the data, but by having Ninox repeat a loop to duplicate or create content for us. Remember these 3 tips. 1, do it server-side. Do as server. 2, optimize your compound select statements by putting them in an order where you're narrowing down the field in the beginning as opposed to at the end. Remember when we looked at the example of sales by country by month? By going by country by month, we narrowed it down to 120,000 and then to get to our 10,000. When we flipped the order, that 120,000 became 50,000. We narrowed it down to a much smaller array. And out of those 50,000, we found our 10,000. We better utilized our RAM. We did the whole thing server-side. And by optimizing the sequence of filters, we made sure that select statement ran as fast as it possibly could. And then finally, if you are building a dashboard where you're going to execute the same query over and over and over again, by month, by quarter, by customer, by year, consider breaking it up into multiple queries. Execute the big query first. Get all of the records that you need to interrogate into one array. Remember to do it on server side. Then query that one array over and over and over again. Don't repeat the selection every single time for every single formula. Something that would end up taking possibly hours if you just leverage the one array that you create one time, could end up taking minutes or even seconds. One last thing I want to remind you of, don't forget about global functions. And if you have questions, refer to the Global Functions training class here on the Ninox Learning Channel by Nioxus. Global functions allow you to reuse a block of code the same way this single query, this single array, was able to be reused over and over again here on this screen. So for that fourth tip, check out global functions. They can also shave minutes, seconds, significant time off of your processing time to deliver a Ninox solution that runs much, much faster. That's our class for today. Thank you so much for joining me, and thank you for being part of the Ninox community. We're looking forward to seeing you again in the classroom, and in the meantime, take these tips and tricks that you've learned today and think about how you can apply them to your databases to supercharge the speed, to optimize the performance, and to take your Ninox database solution processing times to the ultimate, best, most efficient and effective level. Thanks for joining me today. Have a great time with Ninox, and we'll see you again very soon. Bye-bye, everybody.